Okay, today I want to talk about our lab this week, which is gravimetric analysis. So this is a method that chemists usually use to try to identify an unknown compound. And the way this is going to be done is to precipitate one of the components of that unknown compound, usually an ion, by reacting it with something else that causes it to form a solid product. We would then take that solid product, isolate it, weigh it, and then using stoichiometry that you learn in class, we're going to try to back calculate and figure out what our unknown is. So the way this is going to work for you is you're going to be carrying out a reaction where each of you is going to be given an unknown sulfate salt. So this could be sodium sulfate, potassium sulfate, or any kind of sulfate salt that's soluble. All of the identities would be listed in your lab manual. You're going to take that sulfate salt, dissolve it, and then react it with barium chloride. As it happens in this reaction, the sulfate from the unknown sulfate salt is going to react with the barium to form barium sulfate, which is a solid precipitate. What we're going to do is isolate that white solid precipitate, weigh it, and then using molar mass and percent composition, try to work back to figure out exactly where unknown sulfate is. So here's how it's going to look like in terms of the actual experiment. Each of you would receive a vial that contains a white powder like this, and this is your unknown sulfate. There's a code number on it that you have to write down because each code number corresponds to a specific unknown sulfate. Unknown sulfate is usually placed in a glass container that looks like this, which is called a desiccator. The purpose of having it in here is to make sure that the unknown sulfate is dry when you're doing your experiment. What I mean by that is that the unknown sulfate does not contain molecules of water attached to it, because if it contains molecules of water, the molar mass of that unknown sulfate will not be exactly the same as when it is dry. In other words, if it contains some water, what you have in there is not an unknown sulfate, but it's an unknown sulfate hydrate. And the molar mass of a hydrate is different than the molar mass of just the pure compound itself. The issue then will be when you're doing your stoichiometric calculations, your calculations will give you an error because the molar mass you're using is the wrong one. So here's an example. Let's say your unknown sulfate is magnesium sulfate. If it's exposed to air where it contains water, it might bond with some of those water and form magnesium sulfate heptahydrate instead. And clearly the molar mass of this hydrate is different than the molar mass of just the sulfate alone. So what we do is in the desiccator, we put a bunch of compounds that will absorb water. These are compounds called hygroscopic compounds. And the purpose of those is to make sure that all the sulfate salts remain dry. The next thing you want to do is take that unknown sulfate salt and weigh about 0.3 to 0.35 gram of the white powder in the balance room. And the reason we need to make sure that the mass is around this value is to ensure that the unknown sulfate be the limiting reactant in this reaction. One of the things you want to think about is why is it important that the unknown sulfate be the limiting reactant in this case? What assumptions are we making when we're doing our stoichiometric calculations such that the unknown sulfate has to be the limiting reactant? Okay, so once you have that unknown sulfate weighed, you would place it in a beaker and then you're just going to add some water to dissolve it. This is going to be distilled water. And then afterwards, you're going to do a couple additional things. You're going to add HCl, which is not a reactant, but it's actually something that you add to help you form nice looking precipitates that will later on help you isolate the solid a little bit easier. The next thing you're also going to do is you're going to heat the solution until it just boils, and again let it cool down afterwards. That step has again to do with forming better quality solids that will both make the calculation more accurate and make the recovery of the solids easier. So when the solution is cooling down, that's when you should add the other reactant, which remember is barium chloride. And this is going to be added in excess. So the lab procedure tells you to add a certain volume of barium chloride, and you're going to do that. The best addition is done through a dropper, as shown in this picture right here. You can also pour that barium chloride in, but usually pouring will result in a lower quality crystals, which means you're going to lose some of it during the procedure later on and your calculation will be wrong. Now, once you add all your barium chloride in there, you have to wait 20 minutes to make sure that your barium sulfate solid is completely formed. While you're waiting, you should check out a crucible and a lid, which is an equipment that looks like this. This is going to be used later on to isolate the crystal. Now, what you need to do with that crucible and lid is you heat it to make sure that all the water and everything else that's in here is evaporated. And then you're going to weigh the mass of that crucible with the lid on just to see what it is as an empty crucible and lid. Once you have waited 20 minutes after the addition of barium chloride, then what you're going to do is you're going to filter your barium sulfate. Remember, that's your solid. And then, because your filter paper will be mixed with the barium sulfate solid, you're going to decompose the filter paper that's done in the crucible. And then at the end, you're going to weigh how much barium sulfate you have. This shows you really quickly how to filter the barium sulfate precipitate from the rest of the solution. So you're going to fold your filter paper into quarters so it looks like this, and you're going to open one side of it so it looks like a filter, just like a coffee filter. You put that in a funnel, and then basically what you do is you just pour the solution that contains both the barium sulfate precipitate at the bottom and the solution, pour that into the funnel to filter the precipitate. So as you pour this, at the end, the precipitate should be stuck with the filter paper. The solution that you don't want should be collected here at the bottom, maybe in a flask. Once the filtration is complete, this is what you want to do. You want to set the following up inside a fume hood. You're going to have a ring stand, the crucible, and the lid that you have earlier that you have heated. You take a Bunsen burner and a tubing, connect it to the gas line in the fume hood, have a clay triangle so you can put your crucible on top of it, and a pair of tongs in case you need to remove the lid of the crucible when it's hot. Next thing you do is you put that filter paper that contains the barium sulfate and it's still wet, put it inside the crucible and heat this until the filter paper disappears. Now, just a reminder about Bunsen burner in general. This type of flame is what we call a low heat flame because the heat of the flame here is not as hot as if you make the flame go blue like this with the inner cone. So as you can see, hopefully, that this one has that little bit of an inner cone. That's the hottest type of flame you can get in a Bunsen burner. So when you start heating your paper in the crucible, you actually don't want your flame to be too hot. So you want to shoot for something that looks a little bit more like this. Bluish, maybe a little yellow, but mostly blue, but no inner cone. As your paper in the crucible starts to turn brown and then black and then ash and then eventually completely decomposes, you want to heat up your Bunsen burner. This is done by turning a little knob that's located slightly above the most bottom part of the Bunsen burner. There are two knobs that you can turn. You don't want to turn the one that's the most bottom because that controls the gas. You want to turn the one that's slightly above that, which controls the amount of air or oxygen that goes into the Bunsen burner. That would allow you to set the flame to be very blue with the inner cone inside. Sometimes the paper inside the crucible might catch fire. This is probably because you set up the Bunsen burner flame a little too much at the very beginning. So if your paper does catch fire, what you need to do is use the pair of tongs that you have, pick up the lid, and cover the crucible. The fire will need oxygen in order to continue burning because the crucible is covered. There's no more oxygen that goes into the crucible, and as a result, the fire will die. As soon as the fire dies, you pick up the lid and open it again and continue heating as before. One last thing. It's not uncommon that if you were to use the lid, you're going to see this tar that is on the lid or on parts of the crucible. These all have to be heated away using the Bunsen burner as shown here. When you weigh the crucible with your product, it should be white as when you started because any additional mass that you have on your crucible would cause you to have the wrong values in your calculation.